This is the first set of problems for section 1-2 in MA104. The first problems ask us to rewrite in inequality notation and graph on a real number line. These problems are written in interval notation. We can tell by, in number 5, the closed brackets that are around it, and in number 9 we have the closed bracket around the number and then the open parenthesis around the infinity sign. Remember what an interval means. It means that this first number is the very first number of our interval, and because we have the closed bracket, we're including the -8 as part of our interval. The last number is +7, and again, because of the closed bracket, the 7 is included. And we're also including every single number in between those two, every real number, so fractions, decimals, integers, whole numbers, everything that's between these two values is a solution to this particular problem. So to graph that on a number line, first thing we need is a number line. So here's my number line. I want to anchor it with the 0, put the -8 on the negative side and the +7 on the positive side. Again, because the -8 has a closed bracket, we are actually including the -8 as part of our solution. Anything that's a solution is covered, so we want to close in that circle. Same thing with the +7. The closed bracket means that we are including it, so that will get the closed circle. And we also know that everything in between is also a solution, so we will shade everything in between. So the shaded numbers, or the numbers that are covered on the number line, represent the values between -8 and +7 inclusive. That's graphed on a real number line. To rewrite this in inequality notation, x can be any number that we have covered. So the way that we would write it is that -8 would be less than or equal to x, which is less than or equal to +7. We know that x has to be larger than or greater than or equal to this -8. The or equal to comes from the idea of the closed bracket. We also know, though, that x has to be less than or equal to +7. The or equal to comes from the bracket. For number 9, in this case, our interval goes from -6 to +infinity. So if I want to graph that on a number line, again, I have the 0, here's the -6. Infinity is a concept or an idea. It's not an actual number, so we don't actually put it on a number line. Infinity just means that we're extending our answer forever, in this case in the positive direction. For the same reasons we talked about before, we will include the -6, so that gets covered. And then we also want to include anything larger than that, so we're going to shade or cover up everything that's greater than that -6. We color in the arrow to indicate that our solution keeps going. To write this as an inequality, you never write infinity as part of an inequality. We only want the variable, and in this case the -6. X can be anything larger than -6. X could also equal -6 because of the closed bracket. So if I put that idea together, this gives me, this gives me that x is greater than or equal to -6. This is inequality notation. This is graphed on a real number line. This that we started off with is interval notation. All three of these values represent the same amount. They all represent the same information. This problem asks us to rewrite this inequality in interval notation. Well, again, in interval notation, we want to start with the smallest value x could be, so in this case it's that -7, and then we want to end our interval with the largest value x could be, which in this case is 8. We group them with the open parentheses, because even though my interval starts at -7 and ends at 8, because these are just less than, I don't have that or equal to, then I'm not actually going to include them as part of my solution, so that gets the open parentheses. To graph on a real number line, again, to graph something just means that I'm covering the solutions. I'll get the 0, the -7, and the +8. I don't want to cover the -7 and the +8 because they're not technically solutions, and I can only cover solutions. So I'll leave those as open circles, but what are solutions are every number between them. So I will shade in between. This one gives us the graph and asks us to write in both interval and inequality notation. Well, you can see that this particular interval starts at -7, there's -6, and there's -7, 0, 1, 2, so it ends at 2. So in this case, my interval starts at -7 because of this closed bracket, and the closed bracket on the number line is another way to indicate this. We're covering that solution, so we'll include that bracket as part of our solution for the interval. And then my solutions end at +2 with the open parentheses. So this is interval notation. Inequality notation just means that I want to indicate that x could be anything that's covered or anything that's shaded. So I would say that -7 is less than or equal to x, which is less than +2. X is any number between those two values, so I put x between it in this particular inequality. To solve an inequality, I solve this using the same steps that I used to solve an equation. I just have to remember the rule about changing the direction of the inequality symbol if I multiply or divide by a negative. So in this case, I want to start off by subtracting that 4x from both sides. I'm just subtracting, so I don't have to do anything with the inequality sign. 7x minus 4x is 3x. I still have the -8 is less than, my 4x's cancel, and I get 7. Now I can add that 8 to both sides, which leaves me with 3x, my 8's cancel, is less than 15. To finish it off, I'll divide both sides by 3, which leaves me with x is less than 5. 15 divided by 3 is 5. I do not have to flip the sign. I don't have to change the direction of the inequality sign because I only divided by a positive number. If I want to graph this solution, again, to graph just means that we're covering the values that work. So I want to graph every number that's less than 5. I'll put the 0 to anchor it, and my +5. I'm only interested in the numbers that are strictly less than 5. I don't actually want to include 5. So I will have an open circle and shade everything to the left. In this case, I have to start by clearing my parentheses and distributing that 2. So this gives me 12 minus y is greater than or equal to, if I distribute the 2, 2 times 9 is 18, minus 2 times 2y is 4y. To move the y terms to the left, I can add 4y to both sides. I am only adding, I'm not multiplying or dividing by a negative, so I don't need to worry about changing the sign direction. I still have the 12. Minus 1y plus 4y gives me plus 3y is greater than or equal to my 4y's cancel, and that is 18. If I subtract the 12 from both sides, my 12's cancel, and I get 3y is greater than or equal to 6. Divide both sides by that +3, so nothing happens to my sign. I'm left with y is greater than or equal to 2. To graph that, there's my 0, there's my 2. Because it's greater than or equal to, I'm including the 2 as a solution, so I'll cover that up by closing in the circle and then graph everything to the right. In this particular problem, the only reason that the variable is not by itself is because of the divided by -2. To get rid of a divided by -2, I will multiply by -2. So that's n over -2. And then I have to do the same thing to the right as I did to the left, so that's -2 times 4. This time, because I am multiplying by a negative number, I have to flip the direction of that sign. So greater than becomes less than. The -2 divided by -2, those -2's cancel out, and I'm left with n is less than -2 times 4 is -8. The variable's by itself, so it is solved. To graph, I have the 0, I have the -8. This gets an open circle because of the strictly less than. and I will shade everything to the left. Same thing here, the only reason that t is not by itself is because of the -5, so I will divide by -5. When I divide both sides by a negative, I have to remember to flip that sign. So less than becomes greater than. -10 divided by -5 is +2. So this gives me t is greater than 2. To plot that on a number line, there's my 0 and my 2. I get the open circle because it's strictly greater than, and shade everything greater. I'll start this one by distributing the 4, so I want to take that 4 to each term inside the parentheses. That leaves me with 3 minus m is less than 4 times m is just 4m, minus 4 times 3 is 12. I can subtract the 4m from both sides. So I have 3 minus m minus 4m altogether gives me minus 5m. I'm only subtracting, so I don't have to do anything with the sign direction, so that will stay less than. My 4m's cancel, and I'm left with -12. To move that constant over, I can subtract the 3 from both sides. My 3's cancel, and I get -5m is less than -15. Divide both sides by -5. Because I am dividing by the negative, I have to flip that sign. So the less than becomes greater than. -15 divided by -5 is +3. So m is greater than +3. There's my 0 and my 3. We have the open circle and shade everything greater than. In this case I have fractions. So my denominators are 4 and 3. The common multiple with 4 and 3 is 12. Every term will get multiplied by a +12.